video, we're going to talk about equivalent ratios, and we're going to start off by looking at word problems with equivalent ratios, but then we're going to talk about equivalent ratios in graphs and tables. Alright, so to start off with, the word equivalent is a word that we have seen a lot. We've talked about equivalent fractions, we've talked about equivalent decimals, we've talked about equivalent a lot throughout the year. And what the word equivalent means, just as a quick reminder, is equivalent means equal. Okay, so let's go ahead and get started. So equivalent ratios are a lot like equivalent fractions. They are two ratios that have the same value, even though they look different, okay? And so there are two ways to check to see if you have equivalent ratios. And it is a matter of preference. There's no right way or wrong way. You can use any method that you would like, and you're going to get the correct answer no matter which way you do it in any situation. So the first way to check is by division. So equivalent ratios, once they're set up, they will look like this. They will be set up as almost like a fraction equal to another fraction. And what you will do in the first method is you will take each one and you will divide them. So you will do, for example, 60 divided by 5. And when you do 60 divided by 5, you're going to get 12. And then you're going to go to the other side of the equal sign and you're going to do the same thing. You're going to do 144 divided by 12 and you're going to get 12. Now, if you get the same exact answer when you divide both of those, then you have a set of equivalent ratios. If you get a different answer, then they are not equivalent. Now, another way to check to see if they are equivalent ratios is to cross multiply. And the way to do that is to do exactly what it says, cross multiply. So you take the bottom number and you multiply diagonal with the number across from it. So 5 times 144 is 720. Then you go the other way. 12 times 60 is also 720. So similar situation. If you get the same product when you cross multiply on both sides, then you have a set of equivalent ratios. If you get a different product, then your ratios are not equivalent. So let's take a look at some basic word problems. So here we have 20 miles in 5 hours, 45 miles in 9 hours. Okay, so the way that we're going to set it up is we're going to take the numbers in the order that we're given them in the word problem. So we have 20 miles in 5 hours equals 45 miles in 9 hours. What we want to make sure that we're doing, though, is that we are setting them up so that we have miles on, if miles are on top over here and hours are on the bottom here, we also have miles on the top over here and hours on the bottom over here. That's going to basically be the, the only requirement in terms of order. So now, for this one, what I'm going to go ahead and do is use the first method, and I'm going to divide. So 20 divided by 5 is going to give me 4, and 45 divided by 9 is going to give me 5. So I have different quotients here, and so the answer is no, they are not equivalent ratios. All right, so the next problem here, I have 3 t-shirts for $21, and then I have 5 t-shirts for $35. Now, whenever I'm dealing with money, money always goes on top. So I'm going to have $21 over 3 t-shirts equals $35 over 5 t-shirts. And for this one, I'm just going to use the second method just to switch it up and show you how it works. So 3 times 35 is going to be 105. And then 5 times 21 is also going to be 105. And so these are equivalent ratios. So that's a yes and a no at a very basic level, okay? So now we're going to take it up just a notch, and I'm going to have you start explaining to me why they are or are not equivalent, okay? So Felicia read the first 60 pages of a book in 3 days. She read the last 90 pages in 6 days. Are these reading rates equivalent? Why? So we have 60 pages in 3 days, and we have 90 pages in 6 days. So, first of all, are they equivalent? Well, I'm going to go ahead and use division here. So 60 divided by 3, that's going to give me 20. 90 divided by 6, that's going to give me 15. So to start with, no, they are not equivalent. But why? So here's where we're going to start to incorporate unit rates again, okay? So at the base of it, how many pages did she read per day when she read 60 pages in 3 days? Well, I found the unit rate when I divided, because I had 60 pages over 3 days. And when I divided that, I got 20 pages in 1 day. That's how I got 20. And then over here, the unit rate was 15. So what's nice about the division method is that it actually gives me the unit rate, and I can use that to defend my answer, to give me the y. So in my y, I'm going to explain using the unit rate. So no, these are not equivalent because, what's her name? So Felisa read 20 pages per day for the first 3 days, and 15 pages let me move this down for the last 6 days. Okay? And that's how you start to defend your answer. So let's take a look at this one with basketball. So 3 free throws made out of 7 attempts, 9 free throws made out of 14 attempts. So this one's not really asking us to defend our answer. So we have 3 out of 7, and we have 9 out of 14. So is this equivalent, yes or no? So we used division on the last one, so I'll go ahead and use multiplication on this one. So we have 9 times 7, which is 63, and then we have 14 times 3, which is 42. So no, these are not equivalent. All right? So go ahead and try these two. Now, realize it's asking you to explain your reasoning as well. So make sure that you use unit rates to explain your reasoning. Okay, go ahead and pause if you're not done. So for the first one, they are not equivalent. And when you give your reasonings, you need to give your unit rates. So no, they are not equivalent because the bagels are 50 cents each at the first store and they're 38 cents each at the second store. So when you divide this one, you actually get 0.375, but because we're talking about money, I went ahead and rounded to the hundredth spot. For the second problem, yes, they are equivalent, and to prove that with a unit rate, the cost is $4 per book at both locations. All right, try these two as well. Remember, explain your reasoning and defend with unit rates. All right, go ahead and pause if you're not done. If you are done, let's go over it. So in both situations, they were equivalent ratios. In the first situation, it was equivalent because the person made $4 an hour in each situation. In the second example, it was an equivalent ratio because it took 0.4 minutes to drive each lap in both situations. All right, so now that we've looked at word problems, let's look at tables and graphs. So Nivy collects 12 new coins each year. Use equivalent ratios to graph the growth of his collection over time. So if he collects 12 coins in 1 year, how can we use equivalent ratios to find out how many coins he's going to collect in 2 years? Well, if he collects 12 coins in 1 year, then he's going to collect double that in 2 years. So 24 coins in 2 years. So then how many coins will he collect in 3 years? Well, add 12 to that, 36. How many in 4 years? Add 12 to that, 48. How many in 5 years? Add 12 to that, 60. Now we need to take our table and graph it. So we have, this is going to be our x, and this is going to be our y. These are coordinates. So we have 1, 12, 2, 24, 3, 36, 4, 48, and 5, 60. And we should have a straight line there, okay? But we have a follow-up question here. So if Nivy continues to collect coins at this rate, so 12 per year, use the graph to determine how many coins he will have after 8 years. So one of the flaws in our graph is that we don't have it labeled yet. So our x-axis here is years, and our y-axis is number of coins. Now, it wants to know how many he's going to have after 8 years. So this line right here. Well, if we took our line and we kept it on the same exact trajectory, how many coins would he have? It would hit right here, and we would come across, and he would have 96. So the answer is Nivi would have 96 coins. Okay? Let's take a look at the next example. Adina walks at a rate of 3 miles per hour. Complete the table using equivalent ratios. So if she walks 3 miles per hour, that means she walks 3 miles in 1 hour. So then, how many miles does she walk in 2 hours? So if she walks 3 miles in 1 hour, she walks 6 miles in 2 hours. How many miles does she walk in 3 hours? We'll add 3 to this, so that's 9. So then here is the number 12. Well, she walks 12 miles in 4 hours. How many miles does she walk in 5 hours? That's going to be 15. So let's graph these results. So we have 1 and 3, 2 and 6, 3 and 9, 4 and 12, 5 and 15. Let's label. This is our X, this is our Y. So our X, this is hours. And then this is miles. And then we should always put a straight line through our dots. And let's see what our question for this graph says. What does the point 2, 6 represent? So the point 2, 6 is right here. What does that represent? So besides being a dot, what is it telling us? Well, 2 is the number of hours and 6 is the number of miles. So it's telling us that in 2 hours, Adina, am I spelling her name right? Yeah. Oops, no comma. Walks 6 miles. All right, next question. Bethany and Tiffany make bracelets with 8 charms on each one. So first thing we need to do is fill in our table. So 8 charms on each one. So one bracelet will have 8 charms. 2 bracelets will have 16. 3 bracelets will have 24. 4 bracelets will have 32. And 5 bracelets will have 40. Now let's graph our results. So here we have our X and our Y. So our X is bracelets and our Y is charms. So we have 1 and 8, 2 and 16, 3 and 24, 4 and 32, 5 and 40. We're going to make sure we put a line through it. And our question is, what does the point 1, 8 represent? So what is this point right here representing? Well, it's representing that one bracelet has 8 charms. We have another question. How many charms do they need to make 7 bracelets? So this is why labeling is important. So how many charms do we need for 7 bracelets? So we need the 7 bracelets line here. So if we made our line continue on the same trajectory, how many charms, so here's where it meets, how many charms do we need? 56. 7 bracelets would need 56 charms. Alright, so now we're going to go backwards. We're going to use the graph to complete the table. So if we have one box, and here we have number of boxes, how many bars, number of bars, does that give us? One box, 10 bars. 2 boxes, 20 bars. Now we go 1, 2, space, 5. So that's going to be 3, 4. 3 boxes gives us 30 bars. 4 boxes gives us 40 bars. 5 boxes gives us 50 bars. And that's all we have to do there. We're working backwards. Okay, some multiple choice questions. A graph shows the distance a car traveled over time. The x-axis represents the time in hours. The y-axis represents the distance in miles. The graph contains the point 3, 165. What does this point represent? So the x is time, the y is distance. What does this point represent? Go ahead and pause the video to make your selection. And I'm going to circle the answer right now. So the answer is going to be C. The car traveled 165 miles in 3 hours. Because it said that the x is time, so that would be hours, and this is distance. So this would be miles, which is right here. Last one. Kina charged $11 per hour to babysit. She makes a graph comparing the amount she charges, which is the y coordinate. That's the amount she charges. And the time she babysits, which is the x coordinate. Which ordered pair is not on the graph? So if she has x, y, that's going to be time, money. Which one of these are not possible if she charges $11 per hour? Go ahead and pause the video to make your selection. So the answer is B. It would not be possible for her to work 11 hours and charge $1 total. If she worked 3 hours, she would earn $33, 5 hours, $55, 2 hours, $22, but B would not make sense. All right, that is the end of this lesson. We will do much more practice in class, but let me know if you have any questions.